The motion of a circus clown on a unicycle moving in a straight line is shown in the graph below. After 12 seconds, how far is the clown from her original starting point? So keep in mind, on a velocity versus time graph like this one, displacement is represented by area under the curve, or area bounded between the graph and the x-axis. So in this case, the displacement of the clown is entirely positive, since the area is all above the x or time axis. And so the clown is only traveling in the positive direction. And so to find the total displacement after 12 seconds, which is right here, we need to calculate the area under this graph, all of this highlighted area. So we need to know the area of this triangle, this rectangle, this rectangle, this triangle, this rectangle, and finally this triangle here. We could also find the area by realizing that each square on this graph represents a 2 by 2 area, so 2 meters per second by 2 seconds, which is 4 meters per second. So we could add up all of the simple area that way. So we could see that here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 simple squares that are not involved in triangles. So we've got 11 filled in squares, 11 squares, where each square is 2 meters per second by 2 seconds. So 4 meters, so 11 squares is 11 times 4 meters, which is 44 meters. And then all we need to do is find the areas of these triangles. So starting with the triangle on the far left here, we see, or we know, that the area of a triangle is 1/2 base times height. We see that the base is 2 seconds, so from 0 to 2 seconds is 2 seconds. We see that the height is 6 meters per second. And so the area is 6 meters. Then for the next little triangle here, its area is again going to be 1/2 base times height, where the base is again 2 seconds, and the height is the difference between 10 meters per second and 6 meters per second, so 4 meters per second. So it'll be 4 meters. Then finally, for the last triangle on the right, its base is actually 4 seconds. So the difference between 8 and 12 seconds is 4 seconds. And the height is 10 meters per second. So that's a total of 20 meters. So if we add up the displacements due to the triangular portions of the graph, so this will be displacement of the triangles. We have 6 meters plus 4 meters plus 20 meters, and this is equal to 30 meters. So now if we take the displacement due to the triangles plus the displacement due to the rectangular sections, or the square sections, we'll have 30 meters plus our earlier found 44 meters, for a total area of 74 meters. So this is the total displacement of the clown. So this is how far the clown is from her starting point, 74 meters in the positive direction.